All we are really trying to do in lean manufacturing is to get one process to make only what the next process needs when it needs it. We are trying to link all the processes, from final customer back to raw material, in a smooth flow without detours that generates the shortest lead time, highest quality, and lowest cost. So how can you, on your shop floor, actually get one process to produce only what the next process needs when it needs it? Fortunately, you can follow Toyota's lead and use the guidelines on the following pages. Guideline number 1. Produce to your Takt Time. Now let's understand Guideline 1. Produce to your Takt Time. First, what do we mean by Takt Time? Takt Time is the rate at which you need to produce a product to meet actual customer demand. It is calculated by dividing your available working time by the customer demand. For example, if you have 28,800 seconds available in a day and customer demand is 240 units, your Takt Time becomes 120 seconds per unit. This means every 120 seconds, one finished product should come out. Now, why is this important? Because Takt Time acts like a heartbeat of your process. It ensures that production is neither too fast nor too slow, but perfectly aligned with customer demand. If you produce faster than Takt Time, you create overproduction and excess inventory. If you produce slower, you delay customer deliveries. Next point, synchronization. The main purpose of Takt Time is to synchronize production with sales. Every process step should ideally operate in rhythm with Takt Time. This means each workstation should complete its task within the Takt Time so that flow is maintained smoothly. Now, what do we do in value stream mapping? In the current state map, we compare the actual cycle times of processes with Takt Time. This helps us identify where we are slower than Takt Time causing delays, where we are faster causing overproduction. Now let's move to guideline number 2. Develop continuous flow wherever possible. Continuous flow means producing one piece at a time, where each item moves immediately from one process step to the next, without any waiting, without any stagnation, and without any waste in between. This is considered the most efficient way to produce, because it minimizes delays, reduces inventory, and improves overall responsiveness. However, achieving continuous flow is not always easy. It requires thoughtful process design, proper layout, and sometimes creativity in implementation. Now let's understand how we represent this in value stream mapping. In the current state map, continuous flow is usually indicated simply by the process box. But when we move to the future state map, we explicitly show where continuous flow is implemented. If multiple processes are connected in a smooth flow, we combine them into a single process box. So instead of showing separate steps like A, B, and C with inventory in between, we represent them as one continuous flow. Now, an important practical point. In real-life operations, achieving 100% continuous flow across all processes may not be possible. There could be constraints like long lead times, process differences, equipment limitations. In such cases, we adopt a hybrid approach. That means combining continuous flow with controlled inventory systems, such as FIFO first in, first out. So what should be our goal? Our goal should be to increase the extent of continuous flow as much as possible. As continuous flow improves, flexibility increases. Changeover times reduce. Smaller and more efficient equipment can be used. And overall system responsiveness improves. Now look at the diagram shown here. In the top section, you see isolated islands. Processes A, B, and C are separated, and there is inventory buildup between each stage. This creates delays, increases lead time, and hides problems. In the bottom section, you see continuous flow. Processes A, B, and C are connected directly. Material flows smoothly from start to finish, and the finished product comes out without interruption. Now let's move to guideline number 3. Use supermarkets to control production where continuous flow is not possible. So far, we discussed continuous flow. But in reality, not all processes can be connected in a smooth, one-piece flow. There are situations where processes are far apart, have different cycle times, or require batch processing. In such cases, we introduce a concept called a supermarket. What is a supermarket in Lean? A supermarket is a controlled inventory system where a downstream process withdraws what it needs, and the upstream process replenishes only what is consumed. It works exactly like a retail supermarket. You pick what you need from the shelf, and the store refills it based on actual consumption. Now let's understand why we use supermarkets. Supermarkets help in controlling overproduction, maintaining optimal inventory, linking disconnected processes efficiently. Instead of pushing material forward blindly, we allow the downstream process to pull material. Now look at the diagram shown here. You can see two processes, process A and process B. Between them, there is a supermarket. Process B takes material from the supermarket based on its requirement. Once material is withdrawn, a signal is sent upstream to process A to replenish it. This signal is usually called a Kanban signal. Now let's understand the flow. Process B consumes material from the supermarket. A withdrawal signal is generated. Process A produces only the required quantity. The supermarket is replenished. This creates a pull system, not a push system. Now, an important point while designing supermarkets. We must carefully decide how much inventory to keep. What should be the minimum and maximum levels? How frequently replenishment should happen? Because too much inventory creates waste, and too little inventory creates shortages. Next, let's understand when to use a supermarket. We typically use supermarkets when continuous flow is not feasible. Processes are disconnected. There is variability in demand or production. Now, coming to the symbols shown on the right side. These are standard value stream mapping symbols used to represent supermarkets' inventory Kanban signals. Material flow and information flow. Understanding these symbols is very important because they help us visually communicate the entire system clearly. Let's understand the FIFO concept, which stands for first in, first out. In simple terms, FIFO systems are used to control production between processes by making sure that parts move in the same sequence in which they are produced. So, whatever comes first, goes first. Now, one important point to note is that FIFO systems require some level of inventory. And because of this, they are not as ideal as continuous flow systems, where material moves without any or storage. To manage this, we use something called a FIFO lane. A FIFO lane is basically a buffer placed between two processes. It can hold only a limited number of parts, and all parts are arranged in sequence. The upstream process adds parts into the lane, while the downstream process removes them in the exact same order. Now here comes the control mechanism. If the FIFO lane becomes full, the upstream process has to stop producing. This prevents overproduction and ensures that the system stays balanced. So, wherever continuous flow is not possible, FIFO becomes very useful. It helps regulate production, maintain sequence, and reduce unnecessary inventory. That's the essence of the FIFO concept. Guideline number 4: try to send the customer schedule to only one production process. Alright, let's understand this very important concept in Lean, the idea of a pacemaker process. When we use a supermarket pull system, the goal is to control production in a very simple and efficient way. Instead of scheduling every single process in the value stream, we focus on scheduling just one key point. Now, this point is called the pacemaker process. Think of it like the heart of the system, it sets the rhythm. Whatever pace we set at this pacemaker process, all the upstream processes automatically align to it. They don't need separate planning or scheduling. They simply respond to the pull created by this point. So instead of managing complexity across multiple steps, we simplify control by managing just one process. And this is powerful because it reduces overproduction, improves flow, and creates better synchronization across the entire value stream. In short, control one point well, and the entire system follows. That is the essence of the pacemaker process in a pull system. Now, let's go a little deeper into how the pacemaker process actually influences the entire value stream. First point, any fluctuation at the pacemaker directly impacts upstream processes. If production increases or decreases at this point, all upstream processes must adjust their capacity accordingly. So, choosing the right pacemaker is critical, because it essentially decides how your entire system behaves. Also, the point where you place your scheduling, that determines your lead time boundary. In simple words, from that scheduling point onwards, everything becomes part of the customer lead time, from order to finished goods. Now, let's talk about downstream of the pacemaker. From the pacemaker to finished goods, we should always aim for continuous flow. There should be no supermarkets or pull systems after this point. Why? Because once production is triggered at the pacemaker, the product should move smoothly and continuously till it reaches the customer, without waiting, without interruption. That's why, in most cases, the pacemaker is placed at the most downstream continuous flow process in the entire value stream. And finally, in your future state map, always remember this. The pacemaker process is directly controlled by actual customer demand. So ultimately, your customer is setting the pace, and your pacemaker ensures that the entire system follows that pace efficiently. Guideline number 5. Distribute the production of different products evenly over time at the pacemaker process, level the production mix. Most assembly departments prefer running large batches of one product to avoid changeovers. It feels efficient, but actually creates bigger problems in the value stream. When we produce in batches, we can't respond quickly to changing customer demand. So we end up holding more finished goods inventory, just to be safe, and that increases lead time. At the same time, upstream processes also start working in batches. This builds up in process inventory, and the problem gets worse as we move further upstream. So batching may look efficient locally, but it creates waste across the entire system. Now, what's the solution? We use leveling of product mix. Instead of producing all of product A first and then product B, we alternate in smaller batches, A, B. This improves flexibility, reduces inventory, and helps us respond better to customer demand. Now let's understand the impact of leveling the product mix at the pacemaker process. The more we level our production, the more flexible we become in responding to different customer requirements. This means we can deliver faster, while keeping very low finished goods inventory. Another important benefit, when production is leveled, even our upstream supermarkets can be smaller and more controlled. But, there's a trade-off here. Leveling is not easy. It requires handling more frequent changeovers, and managing different component variations on the line at the same time. So yes, it adds some complexity at the assembly stage. But what do we gain? We eliminate huge amounts of waste across the entire value stream, especially excess inventory and long lead times. And that's a big win. Finally, in value stream mapping, we represent leveling using this symbol, often shown as a sequence like OXOX, which indicates alternating production.